is the uncertainty? Okay, for the expert system, there is certainty. Certains we can determine. For example, parents. Okay, parent. This person is the father for this person. Okay, it's certain. We can determine. Okay, easy to determine. Okay, sibling, sister, and so on. It's easy to determine. Okay, uncertainty is very difficult to make a decision, such as speed, height. Contohnya, okay, this person tinggi, yang ni rendah. Okay, ada yang tinggi sikit, okay, tinggi sangat, okay, very tall and so on. Okay, speed very slow, and ada yang biasa. Okay, it's difficult to make decision because of lack of knowledge. Okay, so we can say that, okay, that situation is the uncertainty. Okay, which is the expert system can handle that one. Okay, because it's difficult to make a conclusion. Sources of uncertain knowledge. The first one with implication, imprecise language, unknown data, and combining the view of different experts. Okay, below into one by one. Okay, for the with implication, okay, the domain expert difficult to make a decision. If condition, then action apa? It's very difficult in the uncertain condition. Okay, in an uncertainty condition. Alright, and then we have imprecise knowledge. Okay, our national knowledge is ambiguous and imprecise. Okay, when we describe something, we must say often, sometime, frequently, hardly ever. And then in expert system, it's difficult to make a decision for if, then, so what. It's very difficult. Okay, so this is limited for the expert system. Okay, limitation for the expert system. And then we have unknown data. The data is incomplete. Okay, missing and so on. Okay, and then we have combining the view of different experts. Every expert have their own perception and opinions. Alright, so they may have a conflict to make a decision. Alright. Expert system handle uncertainty. Okay, dalam nak buat sesuatu expert system tu, okay, macam kita buat expert system previously, okay, mesti ada condition and uncertainty, sometime and so on, and then unless, memang ada. And then expert need to do decision, okay, because it need to choose, because yes or no. Okay, if the rule yes or no and so on. Okay, tak adalah macam tengah-tengah ni sikit, tak ada. Okay, they expert might have a decision to make a rule. Okay, so to handle it usually can really handle uncertainty. Okay, not really. Okay, so the expert system then can handle uncertainty. We can using fuzzy logic. Okay, for those expert system that using a fuzzy logic, we can call it fuzzy expert system. Okay, that we design the expert system to handle uncertainty condition. Okay, then what is the fuzzy logic? Okay, fuzzy logic. Okay, it will describe a fuzziness that involve the theory of fuzzy set. Okay, and then in the fuzzy logic, it will describe how the people thinks. Okay, to attempt to model it. Okay, based on our words, decision making, and common sense. Okay, for example, our words less, more. Okay, and then small, very small, and so on. Okay, it will consider all that. Okay, before it can model it. Okay, it can come up with a rule based on the people sense. Okay, people decision, people language. Word come from the people. Okay, it's based on that. We come up with the rule in the fuzzy logic. Logic and fuzzy logic. In previous traditional expert system, we using Boolean logic. Okay, true or false, member or non-member. Okay, is in the traditional expert system. Okay, in the fuzzy logic, we using a spectrum, just a spectrum of colors. Okay, that we can accepting. Okay, the thing can be partially true or partially false at the same time. For example, one is true, 0 is false. So if our decision, okay, in 0.4, okay, we can say that that is partially true and partially false. Okay, that is the fuzzy logic. Okay, but if in the Boolean is must be true and false, not partially true, partially false, and so on. Alright, that is the difference between Boolean logic and fuzzy logic. Okay, fuzzy logic is a set of mathematical principle for knowledge representation based on degree of membership. Okay, we have a principle of knowledge, and then based on the knowledge, dia punya degree of membership. Berapa degree? Okay, for example 1.4, 1.9 degree of membership. Okay, macam contohnya macam dia tall, okay, tinggi. Degree of membership untuk tall 0.6, and degree membership untuk short is 0.4. For example, dia ada degree. Okay, kita boleh katakan dia tinggi, okay, 0.6 ketinggian, 0.6 dia punya degree dia. Kalau kita boleh katakan dia sebagai short, okay, tapi dia punya degree membership kepada short tu ialah 0.4. Okay, so dia boleh jadi tall or short, tapi must depend on the degree of membership. Okay, we look then, okay, example, this is the non-fuzzy, okay, direct. Okay, maybe we put rule over here. Okay, kalau dia rendah, start pada tinggi ni rendah. Okay, dia rendah. Start pada tinggi ni dia tinggi. Okay, that is the in the non-fuzzy. Tapi kalau fuzzy, okay, we look over here. Okay, dia ada degree of the membership over here. Tengok dia naik. Okay, ini dia punya degree, dia fuzzy. Okay. Okay, macam mana kita tengok. Ini di sini dia bagi example. Okay, ini dia, kalau crepes lah. Kalau set untuk crepes. Okay. Okay, this one dia only 1 and 0. Okay, kalau tinggi rendah for example kan. This one untuk high. Okay, tinggi. Short or tall. Okay, short or tall. Okay, tall is 1. Okay, short is 0. Okay, but in fuzzy, it come up with the degree of the membership is just like that. Okay, untuk place 1 is 0, but fuzzy is just 1 and 0, and then you have a spectrum. Okay, just like a spectrum of color. Okay, 0.01, 0.06, and so on. Alright. Okay, we look into then we come up with the graph, which will become like that. This one is the degree of membership. Okay, for example, if the person is belong by 170, it will become short. Alright. If he is 200, okay, 200 centimeters, it will become tall. Okay, and then this one is degree of the fuzzy set for the fuzzy set. Okay, it's become like that. Okay, dia ada degree dia, spectrum dia. How much Okay. And then, okay, this one for crepe set. For example, crepe set, ini dia punya row dia. Okay, if 1, it belong to the membership of the A. This means if we can say A is tall. Okay, if 1, okay, this means 1, so it will become subset of A, is tall. If the person is 0, okay, the value is 0, it's not membership of A. Okay, this means kalau this one kita we said is tall, is not belong to the membership of the tall. Okay, dia ada tall and short. That's all. Okay, ini dia punya rule. Then this one for crepe set, and then for how about the fuzzy? Okay, fuzzy set. Macam mana fuzzy set? Okay, jika 1 and 0 is totally in A, totally kalau A ni tall lah. Totally in A, tall member. 1. Kalau is equal to 0 is not totally in A. Okay, not a tall member. But the difference between creeps dengan fuzzy set, you have this one. Okay, tengok over here, 0 and 1, dia ada tengah-tengah tu how many. Okay, if x is partially in A. Okay, less than if x, okay, jika x ni between 0 and 1, it partially in A. Kita ada decision lain pula. Range dalam tu tak semuanya satu, mungkin ada banyak. Okay, it belong to the, it partially belong in A. Okay, dia ada partially and so on. Because fuzzy, we must put it's partially, alright, in A or tall or short. Dia ada dia punya degree of membership. Alright. Okay, and then this one, if we come up with the figure like this one is short. Okay, average, this one average, and then this one is tall. Okay, and that is a cube set, just straightforward. But in the fuzzy set, it's become like that. It's a trapezium or triangle. Trapezium or triangle over here. Okay, the short, average, and tall. We look over here. Okay, we if the that person is 184. Okay, over here 184. The degree for the average is 0.1, and the degree of the tall is 0.4. Okay, we can say it's tall and average. Okay, if average 0.1 dia punya degree, jika tall 0.4 dia punya degree of membership. So itu difference between crepes. Kalau crepes 184 it belong to tall. That's all. Okay. One thing in fuzzy logic, we use a linguistic variable. Okay. For example, okay, the statement John is tall. So it implies the linguistic variable John take the linguistic value is tall. Alright. So it will use linguistic variable. Alright. Okay, for example. Okay, as an example. Okay. Alright. If one is strong. Okay. Dia guna linguistic ya. Okay. Dia guna linguistic. One is strong, the sailing is good. Okay. If project duration is long, computational rate is high. Okay, if speed is low, dia ada slow, fast and so on. Okay, then stopping distance is short. Okay, it will use linguistic variable in the fuzzy rule. Right, we look over here. Let's take one, and then okay, I want to show this one. Okay, and then this one is the fuzzy set we hash vary. Okay, mungkin kita ada yang previous one we have short, average, and tall. How about if the language, the words the people use is very short, very tall. Okay, where to put in the graph? Okay, the previous one we look over here, it's just like this. Right, short, this one, average, tall. Okay, how about if we have a very short, very tall? Alright, or little and so on. Okay, so we will, so for the very short, it will become, we put just like that. Okay, dia ada dia punya shape. Okay, for very short is like that. Okay, so we can refer. If 185, so it will become very tall. For very tall, how many degrees? 0.0.19. Okay, for example, this one 18 and 19 for example, and degree for tall is the 0.5. Okay, dia ada very tall, and so on. Alright, ini degree for the very tall. Okay, this one. And then if you become just this one 200 is very tall. Okay, dia ada dia punya degree. Alright. And then this one we represent the hedges. Ini dia punya hedges dia punya shape dia tu. And then for a little just like that. Okay, dia ada sikit. Slightly just like that. Very this one. Extremely this one. We can use the graphical representation. Okay, this one. This one more or less somewhat. Okay, because it's represent the words. Okay, the language word using. Okay, and then indeed just like this. Ni dia punya indeed. Okay, dia ada this indeed. Okay. should be rule must form of if then. Okay, if X is A, then what is B? Okay, must come up with the if then. Okay, how we come up with the want to develop in the fuzzy rule? Okay, first of all, we look into our classical fuzzy, our classical expert system if and then. Okay, rule. For example, if speed is more than 100, stopping distance is long. Okay, ini is using the binary logic. Okay, rule 2, if speed less than 40, okay, stopping distance is short. Okay, we using binary logic, if then binary logic. Okay, in fuzzy logic, okay, fuzzy rule use the variable, linguistic variable. For example, if speed is fast, okay, stopping the distance is long. Okay, if speed is low, okay, the stopping distance is short. Okay, you can use slow, medium, fast, and so on. It's represented in our universe. Okay, universe, what we can define is the short, medium, and long. Alright, this is the rule we come out in the fuzzy logic. Alright, okay. Fuzzy rule relate to fuzzy set. Okay, rule must relate to the fuzzy set. In fuzzy system, all rule fire to some extent, or in other words, they fire partially. If the antecedence is true to some degree of membership, then consequence is also true to the same degree. Alright, and this one we come out, how to come up with the decision later on is based on the degree of the membership. Okay, kita tengok dia punya degree of membership. Okay, dan baru kita akan fire dia punya decision. Alright. Fuzzy expert system. Okay, for example, we have a case study here. Macam mana kita nak buat satu fuzzy expert system tu? Alright. First of all, this is a situation first. Kita ada satu service center. It will keep the spare part, dia ada spare part. And then dia ada repair. Dia akan repair juga fail. Yang mana yang spare part yang fail, customer bawa. Okay, dia akan ganti baru lah. And then yang lama yang rosak tu dia akan repair and jadikan sebagai spare part. Okay, and that is placed on shelf and become spare the objective. Okay, so kat sini dia punya objective. Okay, dia nak make to advise the manager. Okay, to make a service center on certain decision policies to keep customer satisfied. Okay, apa yang dia nak buat for the customer satisfaction. Okay, customer satisfied dengan dia punya service. Okay, dia customer datang minta tukar apa semua, apa barang apa semua, it must be satisfied. Okay, so you want the objective is that. Okay, so we look into this one. This is the process. Okay, first of all, we need to determine the problem and define the linguistic variable. Because fuzzy logic using linguistic variable. Okay, apa variable dia? Little, short, more, than, okay, medium, large. Okay, we must determine first. And then after we determine the linguistic variable, we determine the fuzzy set. Keluarkan dia punya fuzzy set. Set of the fuzzy. And then elicit the construct fuzzy rule. Kita perform a rule. Buat rule. Okay. Terhadap fuzzy set tadi. Make a rule. And then we encode the fuzzy set, fuzzy rule, and procedure to perform fuzzy inference into the expert system. Okay, we encode both of them. Okay, and then we evaluate and tune. Okay, must be evaluate the system. Okay, efficient or not. Okay, meet the objective or not. Alright, this is the 5 step. Alright, so we go to the step 1 first. And this one is step 1. Identify the problem. What is the problem? What is the objective? Okay, and then please define the linguistic variable in there. Okay, so we have for the customer satisfaction, we have average waiting time kat sini, repair utilization factor of the service center P, and the number of server S, and initial number of spare part N. Okay, ini dia punya variable lah. Okay, variable over here. Okay, so we make it become like that, like this. Okay, for linguistic value, we have very short, short, medium. VS, very short, short, medium. Okay, for the number of servers, small, medium, and large. Okay, repair utilization factor, low, medium and high, and number of spare. Right, very small, rather small, medium, ada rather, guna rather large, and very large. Ini dia punya numeric range. Okay, must between 1 and 0 and 1. Okay, 0 until 1, what is the range? Okay, for very short, 0 until 0.03. 0.3. Okay, for short, 0.1 until 0.5. Okay, ini kita akan guna nanti nak plot graph. Nak plot dia punya graph lah. Alright, you need to use this one. Okay, nak plot you punya shape kat graph tu kan, must use this one. Okay, this done. Step 1, we look into the chapter, step 2. Chapter 2. Okay, determine fuzzy set. Okay, this may, and then we determine the fuzzy set. Okay, fuzzy set can have a variety of shape. Okay, however, a triangle and trapezoid. Okay, basically kita guna triangle lah, or trapezoid lah, often provide in the adequate presentation of the SPL language. Okay, kita buat dulu dia punya fuzzy set. Okay, gunakan shape, baru nampak sikit dia punya how to represent our fuzzy set. Okay, look over here, this one. Okay, we must separate between the variable. For this one is for mean delay. Mean delay, we have very short, and medium. Okay, ini based on the range tu tadi, numerical range. Okay, so we plot just like this. Okay, ada triangle and trapezoid. Trapezoid, okay, this one for the mean delay. Sorry. And this one number of servers. Right. Repeat utilization factor. Number of spares. Alright, that step 2. Buat dia punya set tu dulu. Okay, dia punya graph like this. Okay, mapkan dulu how it looks. Basically, in the middle, we become a triangle. And at the beginning or and the ending, at the ending part, should be in the trapezoid. Okay, so like this, just map it like this first. Okay, and then step 3, you need to elicit the construct fuzzy rule. Okay, kita buat the rule. Dah dapat macam ni, buat a rule. Okay, for this one, we need to ask an expert to describe. Okay, macam mana dia solve benda tu. Okay, to solving the fuzzy linguistic variable defined previously. Okay, usually it really needs to knowledge from the other sources, book, computer database, flow diagram and so on, and observe the human behavior. Okay, ini kita nak collect data. Okay, untuk buat dia punya rule tu. Okay, ini baru dia punya set. Okay, kita nak keluarkan dia punya rule tu. Right. So, ini rule table dia. Rule table. Okay, VF very short, SL, VS. Ini dia punya rule dia. Okay, come out. Okay, jika very short apa, and then this one apa dia punya action dia. Apa dia punya result dia. Okay, we come out with this table rule. Okay, ini for example like this one. Okay, if utilization factor is L, then number of spare is S. Okay, ini adalah dia punya rule dia. Kalau mean delay, number of survey small, number of spare this one, if this one. Okay, apa dia punya result? Okay, ini dia punya rule. Okay, if and then apa? Sorry. Okay, if utilization is L, then number of spare is S. Ini dia punya rule. Okay, if then lah, if then. Okay, if delay, then number of server is S. Okay, very small, number of server is S. Small, then the number of spare is very low. Ini dia punya rule. Okay, and then after kita dah ada rule, kita must encode the fuzzy set and fuzzy rule. Okay, and proceed to perform fuzzy interference into the expert system. Okay, to accomplish that, okay, you can choose using the C++ or Pascal. Memang this one memang ni lah, for scratch lah. Okay, this mean from the basic. Okay, Pascal ni lagi lah. Alright. Or to apply fuzzy logic development tool. Kalau guna tool mungkin mudah sikit. Kalau kita ada tool, you can perform using MATLAB Fuzzy Logic Toolbox or Fuzzy Knowledge Builder. Okay, ini dah ada dah toolbox dalam software. Alright. Okay, after that, after we encode both of them, we must evaluate our system. Dah develop dah fuzzy rule system, fuzzy expert system, you must evaluate. Okay, efficient ke tak, meet tak you punya objective. Alright, tu nak evaluate, and then after you evaluate, you must fine tune. Okay, firstly you must test lah, depend on the mean delay, number of server and so on. Try to evaluate. Okay, and then and then dekat fuzzy logic toolbox pun boleh generate surface to help analyze the system performance. Boleh tengok performance dia dekat fuzzy logic toolbox. Okay, and then untuk fine tune kena tengok balik dia punya shape. Okay, dekat fuzzy set tu tadi, tengok dia punya shape, tengok dia and then dia punya review the variable. Okay, review the fuzzy set kat sini, and then dia punya for this one, tengok dia balik dia punya execution weight. Okay, boleh adjust. Okay, weight dia tu boleh adjust balik. Okay, revise balik dia punya shape tadi saya cakap. Okay, revise balik. Okay, and so on, boleh assume balik rule apa semua. Okay, that's why we need to fine tune and cuba evaluate balik. Right. Okay, I think that's all.